Continuing with the Feynman videos. Alright, so I skipped part 3, 4, 5. Um, you know, conservation, symmetry, and then past and future. They all seem kind of, yeah, duh. I mean, I just don't, there's nothing to make out of that. Yes, conservation seems logical. What goes in, something must come out. Something goes in, something must come out. Yes. No magical something. Symmetry, likewise, mostly. Balance tends to be. Something can't be sustained over much period of time if it doesn't have some sort of symmetry. And then past and present just seems obvious. So, anyway. So then we're on to probability and uncertainty. So this is where he talks about the two-slit experiment. Now he doesn't do it very well, and so I'll just go to a couple of spots in the video. He starts with bullets, and it's very good to introduce this to other people, to laymen, but it's again inaccurate, so I'll just point out. So here's this diagram. Here's your source, here's your first aperture, then you have the two slits. So first, the drawing is not even really close. Okay, first we understand this aperture creates a diffraction of its own, which automatically creates a parabolic intensity. So we know we're not having a consistent intensity of light. It's going to be an inconsistent intensity of light. Very intense in the middle, less intense on the sides. Alright, the slits, the barrier between them, he has them separated by at least 7 or 8 divisions, and the real experiment, the impediment in the middle, is no bigger than the opening of either one of the slits. So it's sometimes smaller than this opening of the slit. So yeah, draw it like this for explanation purposes, but it's just not correct. And then when he describes what happens, he never talks about any single slit diffraction. He just uses big lumps. This is what happens, lumps happen, and that's just fundamentally inaccurate. So, somebody should say that isn't right. If we're going to bother having an experiment that's fundamentally the excuse for some sort of wave-particle confusion or duality or whatever you want to call it, then I think it should be because the experiment's been thoroughly understood. So this is where he adds the wave pattern, which he didn't do very well, but whatever, doesn't matter. And it has this classic going down stuff, which, you see all kinds of stuff on the internet. I'll show some of that later on a Google search. But there's bars, there's intensity. You never see this as the actual pattern. You always see something where they're all the same intensity, and there's a whole bunch of them, and it just doesn't fit whatever that the math they wish it to fit. I've just never seen an experiment where the math actually fits the results. Actually, just theoretically. Anyway, so this part should be something.
About electrons, this curve isn't important in our case. This is the number which arrives. Now, we would like to analyze this curve. And we try this. We say maybe we can analyze this by thinking that the electron through this hole or through the other. So we can close one hole and measure how many come through hole number 1, and we get that curve. Or we can close this hole and measure how many come through hole number 2, and we get that curve.
Okay, so that's just fundamentally inaccurate. Okay, you get a diffraction pattern. Yes, you get a big maxima, and then you get these smaller minima, but you get them. And it's just wrong to imply that you don't, because you do. And that's sort of important. And the important thing is, too, here, that you do get this curve because you created it with the small aperture over here. Theoretically, if your light was a consistent source and it went through one open slit, there wouldn't be any curve. You would have a consistent intensity pattern on the other side, unless there was some diffraction to weaken it as it went from side to side. But you'd have a very flat, like Frankenstein head there, where the light theoretically would go straight through the slit. Theoretically. The substance of the light.
And these two added together is not this, and so this is not the same as N1 plus N2.
Right, so, but that's not that and that added together, so those aren't accurate interpretations of the experiment. So adding two things that don't exist and saying they don't add up, well, yeah, those two things you created didn't exist. That pattern didn't exist. I'm not saying that an exact doubling of two single slit diffraction patterns will add up to the double slit diffraction, because they don't, but they don't for a reason. So anyway, moving on to somewhere around here. Some reason or other.
Hole 1, and those, I know the English is right, I'm just trying to, that arrive via hole 2. So the number, the total number that arrive, well, first, what does this column look like when you add it all together for different positions here, which is just the number that is supposed to come through 1. I watch behind 1, and what do I see? I see this curve. That number column is distributed this way. Just like we thought when we closed hole 2. It works the same way whether we're looking or not. If we close hole 2, we get the same distribution in those that arrive as if we are watching. And likewise, the number in this column that is supposed to arrive via hole number 2 is also this simple curve. Now look.
Okay, so that's what he said again, this simple curve, and that's not accurate. It's not what you get. So, that's wrong. It's incorrect. Just, you know, whatever, to those who think it's okay to be incorrect.
Is the sum of the probabilities for each alternative. That is, you lose the interference. Now, the question is, how does it really work? What machinery is actually producing this thing? Well, nobody knows any machinery. Nobody can give you a deeper explanation of this phenomenon than I have given. That is a description of it. They can give you a wider explanation in the sense that they can do more examples to show how it's impossible to tell which hole it goes through and at the same time not destroy the interference pattern. They can give a...
Yeah, well, again, these are all just statements that this is impossible or that's impossible. It seems clear that possibility hasn't been stretched very hard by anyone.
Wider class of experiments than just the two-slit interference experiment and so on, but it's just repeating the same thing to drive it in. It's not any deeper, it's only wider. The mathematics can be made more precise. You could mention that they're complex numbers instead of real numbers and a couple of other minor points which have nothing to do with the main idea. And the deep mystery is what I described.
Alright, so again, understand that with the two slit, if the light was coming straight, it would plow right into the middle barrier. So again, as soon as you put an aperture in, you create a variable intensity. And nowhere in the math is that variable intensity accounted for. And yet, they say the math works. Well, how can it work when it didn't account for the variable intensity, where the math never asked you how big this aperture was or what this distance was? So it never asked for this aperture size, it never asked for this distance, and yet somehow it knows the distribution of intensity at the two slits. So even though the intensity isn't even at the slits, somehow the math works. That sort of gives you some indication, wouldn't it, that something's wrong? And what they use for the math to decide intensity is they use the magnetic component or the electrical component of these made-up components, the two waves that are going, parallel to each other. So the magnetic component's doing this while the electrical component's doing this, and it's exactly the same frequency, exactly the same wavelength as the overall photon. Yet somehow they're going to figure out the intensity of the light based on math that uses a whole bunch of strangled concepts and terminology, but never asks the question, what's this aperture size right here? And never asks, what's this distance? How can it know intensity without asking those two questions? I'd say it can't. Yeah, that's what I'd say. Anyway, I'll jump ahead, just because it seems appropriate. I'll just play this through until 60 or whatever.
No one can go any deeper today, but only wider. You know? Now, I mentioned probabilities in this calculation. What we're calculating here, this curve, is the probability of arrival of an electron. The question is there any way to determine where it really arrives?
I don't think the actual experiments have been done with actual electrons in this actual form, so that's another part of this whole thing that I don't understand why they use electrons when they don't do the experiment that way with electrons.
We are not averse to using the theory of probability, that is calculating odds, when a situation is very complicated. You throw up a die and it spins so many times in the air with the various resistors and atoms and all this complicated business that we're perfectly willing to allow that we don't know enough details, and so we calculate the odds that the thing will come this way or that way. But here what we're proposing, is it not, is that there be probability all the way back at the fundamental laws. That in the fundamental laws of physics there are odds.
Right, so the whole point is that somehow this photon is carrying this wave information. I guess I'm going to argue that it's not the photon that's carrying it, it's I am arguing, that's actually built into the matter itself. And so, to be clear, okay, here's your two slit. Sorry if the focus isn't great, but that's what you get. Like that. That ain't much of an improvement. Anyway, so you have, this is a representation of the intensity of the light. And as you can see, the most intense light is blocked by the center impediment, and so the least intense light is the ones going through the slit. So that's the biggest difference. If you had a single slit, obviously the most intense light gets through, where it doesn't get through in the double slit. The second argument I would make is that there are these forces that all matter expels, and that ions are arranged in field lines, on field lines around all matter, and that it is actually the photons interacting with those field lines that is creating the diffraction. And so you can see that the most intense light is now going through the most heavy field line, the strongest field lines, where in the single slit the most intense light goes through the weakest field lines. As you can imagine, big fielder lines here for one slit. And you can see that the most intense light would be going through the weakest of the field lines, where in the double slit the most intense light's going through a strong field line. So anyway, that's probably enough of that. What else do I want to point out? I want to get to 60 or so maybe I'll just jump ahead here. 50? Somewhere around here, I think there's something else here.
You can't tell through which hole you're going to see the electron. It's determined by some very complicated things back here. If I knew enough about that electron, it has internal wheels, internal gears, and so forth, that this is what determines through which hole it goes. So it's 50-50 probability, because like a die, it's set sort of at random. And that if I were to have studied it carefully enough, your physics is incomplete. If you get a complete enough physics, then you'll be able to predict through which hole it goes. That's the hidden variable theory, so-called. Well, that's not possible. It is not due to a lack of detailed knowledge that we cannot make the prediction, because I said that if I didn't turn on the light, I should get this interference pattern. If I have a circumstance in which I get that interference pattern, then it is impossible to analyze it in terms of saying it goes through here or here.
Well, he's saying it's impossible, but I don't think there's anything impossible about it. And certainly you could aim the electrons and know what slit they go through, and without interfering with them. And that's the whole point. You don't have to disturb them to know where they went. And it's nothing to do with Heisenberg principles. It has to do with diffraction of light, and there's nothing impossible about it. So anyway, yeah, so I'll go to another video. This is a link I didn't find until recently that Mr. Natural had sent to me, and it's interesting. So this is a guy who did it with single photons, so he says. You know, this Veritasium. And you know, some of my popular videos, 250,000, 60,000 views. Anyway, and so, well, first I'll just show this. So here's the classic. You can barely see it, but there's a line here that's showing the classic mathematical solution. Now clearly at these 2 points, so let's say everything below this line is just noise. So the detector was so sensitive that it detects cosmic rays and other crap, so just all this is noise. So everything below this point here is, let's just call that noise for the sake of argument. And so the first thing that seemed obvious, he was saying, look how well it fits the pattern. Well, it doesn't fit it at all here at the both ends. I mean, it's 50% stronger than it should be mathematically. And it's clearly stronger here by at least 50%. The interesting thing is that everything on these two sides is identically symmetrical from these 2 points. So from these 2 points, this side is just the inverse of this side exactly, which is kind of amazing considering the grotesque errors in here. So in here is where the most grotesque errors are. This should not be here. These higher bars here. And like I said, everything from these 2 points is exactly the same. And so here, there's something went way wrong here, let's say. And this is what it maybe should look like a copy of over here. Why didn't you do the experiment more than once? I mean, that's just such an obvious defect here. You think you would want an explanation for that. But the catch to it is that that defect sort of is replicated on all of these. They all have an imbalance to one side. So something was skewing, you know, these measurements. And but clearly, I mean, there's an effort here to make this line fit that just seems kind of egregious. I mean, here, obviously it can't have a peak up here above all the data because there's empty spaces. And clearly here, there's so few empty spaces. How can you possibly keep the line that low? So clearly these two are much more than they should be. So these two, the results are higher than they should be. These are way above what they should be. And these are above what they should be. And yet he claims this is good data. So, consistent data. So, you know, what can you say? And then it goes to the, here's the pattern he showed from his laser. So let's get that. That doesn't look like it, but I'll see what that is. Hopefully they're not going to play a commercial again. So this is another thing where he superimposed his data on the actual, whatever it is. I'd like to see the actual laser. I know it's down here somewhere. No, young experiment. How come it's not playing? Come on, you bastard. Play! Forced me to reload it, I guess. I didn't play the commercial. I really don't want to do that. Budge. I had no choice. It would appear. Commercial, yes. Bad news there. Not playing. Okay. Yeah, it's not even a commercial you can edit. I love science. I mean, you know, you can't even say, no thank you. You must watch commercial. The longer 15-second commercial. The I must have more money commercial. Anyway, yeah, it's just really annoying. Maybe he ought to do a Patreon just to make some money so he doesn't have to run commercials. Okay, let's see if we can find the right spot again, and then we'll... that ain't what I want. Alright, so here's his results apparently. And this is kind of strange. So he's got some pattern in the up and down direction that seems quite eccentric. I mean, quite strong. So I don't know whether his slits weren't long enough or what they were. But this is what he shows as his results. And then, you know, which also don't particularly look exactly right. But you know, there's a better picture of his laser beam here somewhere. The actual image of his two slit. Damn it. Here's his laser beam thingy. Let's see if they show it here. So there's his laser. It goes through the single slit, then it goes through the double slit, and then he's got a pattern on the outside. Should be right there. Now that's what he's got showing on his screen. Now, I mean, not even close. I mean, right? I mean, if you look at this hardly looks like any, you know, this might look like half the intensity. So this would be your central maxima, and these two look pretty equal to the central maxima. I can't see any difference between these and this. It's very slight, if any. But it is strange that it's all, and it's very barred, which is another part of this thing where, you know, there doesn't look like any gradation going in, you know, going this way. Very little gradation in any of these. They seem like all or nothing. They seem pretty consistent across the whole band. So I don't see any peak and then down. I don't see any peak and down. I don't see any peak and down. It just looks like a bar pattern, very hard bar pattern. So that should be an indicator of something. Anyway, so this is all kind of buggy data for, you know, a video that's supposed to be explaining something. Yeah, I don't know. So anyway, so what else do I want to look at? So I'm sorry, yeah, I should just, I have to do the vectors here, you know, because what I mean, my argument is these little field lines, you know, it comes off perpendicular, and if we figure out the perpendiculars lines, I should be able to, yeah, should be able to figure out this. I mean, that's the wave function, though. The wave function is in the field lines of the matter, not in the photons going through. This is where it gets the interference pattern, which is a pattern of field lines. But anyway, alright, so let's just go to the Google search page, I think. Yeah, there's a lot of crap here. So anyway, here's the intensity again. And so, like I said, his doesn't exactly duplicate, in my opinion, those intensity levels. But whatever, many of them don't. Here's a single slit pattern, double slit pattern. So here's another one showing it as a blob when it's not a blob. It's got humps on the side over there. But look how many there are here. So you got 1, 2, 3, 4, 5, 6, 7, 8. You know, and you're supposed to have the 6 or whatever it was. You know, you're supposed to have this classic 1, 2, 3, and then they start getting really small. So this one's got 1, 2, 3. This one's got 4 before it starts getting really small. So, you know, there's all these differences that are kind of annoying. Just trying to figure out, you know, what's the truth in all of this stuff. Yeah, it just doesn't seem to fit. Let's see if I got that one from the one where they block one of the slits. I do like that the best out of all of these, as it does seem to be saying something. So there's one where all the bunch of slits, and then you can see them on either side. Unusual pattern. Oh yeah, the Young double slit, right, which isn't even here, so I guess I should put his name in. Alright, so they're blobs of light. There's an interesting one with different colors. You can see where the phase is a little bit off based on the color. There's a bit of a phase shift. So anyway, with the original experiment, yeah, everything came out very round. And like the sun that he was using in the experiment. And so that's kind of funny, right? Because it was slits and the image was round, which sort of indicates lensing. Here's another different example. So you've got 1, 2, 3, 4, 5 instead of 4, 3. This one's got a whole bunch of them just going down. Which one is this? Double slit pattern, single slit pattern. Yeah, I don't know. Where's the one that has the... I had it here. So, sorry. Well, anyway, I've done a video on it before, so I don't need to do it again, I guess. Sorry. I wonder what this one was. Blobs here. Anyway, where was I? Yeah, so the original experiment, 1800, you know, uses regular sunlight, and yeah, so it had all did the whole prism thing where the different frequencies started spreading out. So you got the, you know, blue fringes and red fringes on these round circles that were the pattern. That should have been a little bit of a giveaway that maybe there's something else going on here. Like these are just images of the sun, you know, multiple images of the sun. And it's a little different. You know, lensing is a little different than interference pattern. So anyway, I mean, no one's arguing that there's a lensing of waves that's creating a interference pattern. So I don't know. Anyway, alright, so a better video next time. Saying something more definitive, hopefully. But it's just like, you know, the science is pretty questionable. Just, you can't, you know, the other one that's interesting, I find this somewhat interesting, this idea that if you take the pattern of the single slit, the double slit pattern fits inside of it, which is somewhat interesting. You know, it's interesting. So it's like the double slit just creates more divisions inside of what would be the single slit pattern, if the intensities were equalized. So if you took the intensity of the single slit and made it the same intensity as the double slit in terms of the amount of light, the double slit experiment fits inside of the single slit diffraction pattern. So anyway, okay, till next time.